which are not only the bending but it's also like the torsional movements yes, like this is a torsional movement, just in case that the ship wants to dance a little bit. And this is going to be the final mechanical test. We're now trying to develop all the surgeries on this. Now, the other important thing that you have to consider is that we have so many different components. I always kept an eye on trying to develop something that could be put in a kit, so that the surgeon in Iraq or in Afghanistan opens it and he finds all the different ingredients. The aliquoted MSCs ready to thaw, the sterilized, sealed, pre-treated scaffolds, the lyophilized NSCs, the PA mixes. You just have to put it everything together. We develop a proprietary protocol to gel everything on the scaffold, and this is the first experiments on the bone of the rat. So this is a very tiny bone. We applied this screw because the animal committee didn't trust that we could recreate the bone, and so we have to do that. But then in this void space, we put the injectable putty and we test that everything works fine. Now, I said it's injectable, and I wanted to actually show it to you. So this is one of my students putting together the injectable putty. He's putting it in a syringe. The syringe is now loaded. You can, in this case, we're injecting just in a mold, in the mold that we use for the mechanical testing, but you can imagine to have a needle and to inject throughout the skin. We're now doing these experiments. So you put it here, and then you put this whole thing in the cell incubator for 15 minutes, so at 37 degrees, humid condition, doesn't matter. And after 15 minutes, you go back, you take it, you push it out, and this thing is now a solid cylinder with very strong mechanical properties. So it cross-links in vivo at 37 degrees in 15 minutes, and it's very solid. And also, of course, it can be shaped in any size you want according to the bone that you're working on. So that's why I was talking about a Play-Doh. So if you have a long bone, you have a long bone. If you have something like this, should be a vertebra, according to my student. Of course, it's not a good sculpture. And this is like the results. So just I want to show you the different implants. I want to show you that after 4 weeks, you have a complete integration of the scaffolds with the surrounding tissue. You see vessels growing in, vessels going out. And if you start doing the histology, you see a lot of the classical features of a natural bone. You see osteoid, you see osteoclast, and interestingly, you also see osteoclast. Osteoclasts eat bone, so they have no other reason to be there but to eat something. So it means that they actually found bone to eat. And also you can see like infiltrating blood vessels, which are necessary. Now, I don't have time to go through all the different groups that we tested, the different combinations. This is like a lot of work. I just want to leave you with this final picture, which is a color coding of the bone that has been formed ex novo on the scaffold. So where you see green, this is the new bone that after 4 weeks only has been formed in the scaffold. And again, we're trying to do even better. Conclusion, identify the growth factors, the molecules that are needed. We got to the right mechanical properties. We assessed the biodegradation, evaluated all the activities of the stem cells, incorporated all the materials together so that they go together very well, and develop all the in vivo stuff. So again, I really want to acknowledge all the work of this incredible team that I have the pleasure and privilege to coordinate. And the reason why I put that picture is that we did this January the 5th in Key West, and this was the weather. Maybe next year, you might want to consider Florida.
Okay.
Just an idea. Thank you.
We have time for 1 or 2 questions. I think you knocked us all dead. Okay. One question.
So, Schaffmeister from Temple University. So you showed degraded BSA without proteases or anything?
Without that's just temperature. It stayed there in 2 weeks. So
and there's nothing growing on it or anything?
No.
So is it getting chopped up or aggregated?
It's getting chopped off. So
Okay.
we're now doing all the HPLC and MALDI characterization to understand exactly what are the molecular species. We also, I just talked about one of the the graphs, the silver stains. The other silver stain had the trypsin added. So we're doing both. So now if you look at this one has a oops. Okay, can you put back the, yes. You see this as with trypsin in 10 minutes, and you see that the degradation bands decrease, so you can still prevent. And the reason is that the pores are small enough so that trypsin cannot get in.
So this is when it's in the matrix, and then
Yes.
on the right is when it's
Yes,
not in the matrix.
just in solution.
Okay, thanks.
Thank you.